All right, class, let's continue on. So here's what's totally cool about conversion factors. Oh, we got a question. Let's find out how much a house would cost in yen using our conversion factors. How much would a house cost in yen using conversion factors? First, let's just say a real cheapo house would cost $50,000. That would be a house I could afford. So $50,000 equals how many yen? How do we do that? Well, it sounds a little scary, but it's not. Let's just go through it step by step. First, we need a conversion factor to change dollars into yen. Do we have an equality here that can change as dollars into yen?
Oh my, dollar sign.
Not really, but we could say that if 20 nickels equals $1, and if $1 equals 92.5 yen, then we could say maybe, oh, we have one. Never mind, I'm sorry. So, all right, step one, identify the equality. That's what we just did. Step two, identify the conversion factor we're going to use. Well, there's two possible ones. Someone tell me the ones? There's two possible conversion factors we can use for this equality. There we go. 1 equals or we can do it the other way, which is so the question is, which one are we going to use? Here we're going to cancel out dollars and get yen. Okay? So let's do that real quick. Okay, hold on. All right. That's not working. Okay, so let's do that real quick. So we start with what we're given. Oh man. $50,000. Okay. Now here's the trick. You use multiplication with your conversion factor. So multiply. Go ahead and do this with me on your notes if you're not doing it. Okay, and we say $1 is equal to 92.5 yen. The Japanese currency. So now let's do a little algebra. Our dollars cancel. Does that make sense so far? Any questions? Dollars cancel, and the unit we're left with is yen. So somebody plug that into your calculator and tell us what you get. 4,625,000 000 yen. That's a lot of yen. Well, how much sake could you drink with $50,000? It's the same. All right, class. Let's do some problems together. Up, next one. Let's practice with other conversions. Please open up your workbook pack. Take out a clean sheet of paper because this is a different assignment. Thank you for doing your notes. Open up your workbook pack for conversions and open up to the first page and just go to the same place that I go on the camera. The very first page looks like this. You can read if you want all that paragraph, but there's one thing I want you to see. And that one thing is right here. Just a moment. It's this little flow chart. When you're doing a conversion, you want to first start with the quantity given. And as you do your problems, if you don't know what to do, and this is important, if you don't know what to do in a problem, come back to this and look at the flow chart. Start with the quantity given. Next is state the relationship between the unit given and the unit sought. Okay, then you find the relationship between unit given and unit sought. Okay. Then you use inequality to write possible conversion factors. you find the right conversion factor, apply each conversion factor successfully to what the units, so that the units cancel properly, and then you have the quantity sought. You go through these steps. Mr. Worley, this is so long and tedious. We're just doing a couple calculations here. Now I know. And the first couple we're going to do should be long and tedious. You know, have you ever seen the movie The Karate Kid? Yes. Anyone? And you know Mr. Miyagi's like, do the kata really slow. He's doing like moves in slow-mo. But when it came to fight time, he really, you know, he did a good job because it was quick. Your brain is going to do this instantly after a couple of tries. So don't despair. It's not going to take forever. All right. Let's look at an example. Somebody warn me when we get to 10 minutes. Okay. Sample. A small bottle contains 45.5 grams of calcium chloride. What is the mass of calcium chloride in milligrams? I've got a question. Just a moment. So here's a sample problem. A small bottle contains 45.5 grams of calcium chloride. What is the mass of calcium chloride in milligrams? Okay. So this is just the same thing we did before. They write the given, the units of quantity, relationship between the units. This is the equality statement. 1 gram equals 100 milligrams. How do I know that? You need to check in your book in section 2.2. There's a table that tells you what the equalities are. So I'd say 2.2 table. Is it table 2? It looks like it's table 2, yes. It'll tell you what the equalities are, all right? And the conversion factor in the milligrams chloride. Okay, so let me move it down and look exactly what they did. First they said, we want this. We're going to write the relationship. We're going to write the relationship between grams and milligrams. So 1 gram equals 1,000 milligrams. So far, are you following me? Any questions? Okay, so I'm sensing a little confusion on how to find out what the relationship is between grams and milligrams. Okay, let's check it out. Everyone go to your book. It's on page 35. Page 35, here's our table. All right, so here are the prefixes: tera, giga, mega, kilo, hecto, deca, nothing. This nothing represents the base unit. And in our SI unit, gram, well, gram is the base unit. Okay? So deci, centi, milli. Oh, okay, here's milli. Milli means 10 to the negative third, or 1,000th. So this is how I know that 1 gram equals 1 milligram equals 1,000th of a gram, or 1 gram equals 1,000 grams. If you need more explanation on how I got to that number, raise your hand now. Okay, Nigel, ask me a question. Okay, so let's do an example. We're going to start with grams, and we want to have a conversion factor for, someone give me any one of these. Nanogram? Attogram. Oh my goodness. Okay, so what is the conversion factor for attogram? Okay, so here's how we do it. We look at our chart. Here's atto right here. Oh my goodness. Atto equals 10 to the negative 18, or 1 over that insane number. Okay, so go ahead and open the door.
Maybe that's me. He's the door. I'm the door.
Okay, so what you see this fraction right here? Yeah. What this fraction means, I'm going to write it here on my card. It means 1 gram. That's what the 1 means. 1 gram, or 1 of any of the base unit, is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 attograms. The 1 goes on the top right there, and this is attogram. Now that we have this equality, we can write it in a different way. We can say